Okay, so parent functions. How many years have y'all been studying parent functions? Many years. Let me change this here, zoom out just a little bit. Many years. That doesn't mean you know them all, but there's some that I think you probably know better than others. Okay, so notice we're skipping linear. You need to know that. I mean, we're not going over y equals x. You need to know it, but we're not going over it. Okay, you also need to know domain and range, and you need to be able to look at a graph and know what the parent function is. So what do we call y equals x squared? What's the name for that? Quadratic. Okay, and you should be easily graphing this parabola. 0, 0, 1, 1, 2, 4, 3, 9, and then it mirrors over here. And obviously there could be some transformations, but this is what the parabola looks like. And we just studied parabolas even in conics. So what is the domain of that y equals x squared? What are the x values here? Goes forever left and forever right, so we call that all real numbers, which I'm going to go ahead and call negative infinity to infinity. And then what would the range be? What are the y values? 0 to infinity. And infinity symbols always have parentheses because you never reach infinity. This 0 could be a parenthesis or bracket. It depends upon the problem, which is it in this case. It actually equals 0, so there's a bracket. And if you think about it, there's a point here. If there had been an asymptote here instead of a point, then we would use a parenthesis there. So it says, what is it that creates this domain and range? Okay, so this is what I'm asking here. Domain is all about input. And then likewise, range is about output. Okay, so what can you input into being squared? Like what type of numbers can you square, or are there any numbers that you can't square? If I said, I want you to square this number, could you do it? Or are there some numbers you're like, it's impossible to square? I'm not saying in your head. I'm just saying, is it possible? You can square anything. All right? If you make this connection, this stuff becomes a lot easier to remember. Okay? Your input can be anything. Whoops, can. Are you guys okay over there? Do we need to move some seats? All right, your input can be anything. You can square anything, as opposed to square rooting. You can't square root everything. We'll get to that one in a minute. So the range then would be the output. So if you think you can square anything, well, what happens when you square a number? It gets squared, but what else always happens? Charles, you're about to get embarrassed on this video here. You already are a little bit, because that's recorded.
Roberts.
Charles Roberts.
Harrison's the middle name.
Charles Harrison Roberts.
I'm a
Okay.
junior.
Okay.
First year
All right,
football,
enough.
second period.
All right, so what is the output? When you square a negative number, it becomes positive. You guys know this, but this is what I mean. This is what's going to help you remember that type of thing when you're not sitting there looking at a graph. Okay, the output, it can be 0, or it's positive. The output cannot be negative. Okay, so that's another way we could have said this. These questions right here aren't so much like I'm going to ask you that question. It's more like this is how you're going to remember this stuff for years and years, depending upon what kind of math you take. All right, so it says, what mini picture can you think to remember this function? A U, a parabola. It can be right side up. It could be upside down. All right, so here's what I would like for you to do. As much as you can for this problem. I want you to do as much as you can, and I'm going to pause here. Okay, so you probably haven't finished here, but hopefully you've at least come up with the name of this function, which is Square root. Did anybody write something else down that started with an R? Anybody write down radical? Some people call this radical. Radical is just root. It could be root, cubed root, anything, but a lot of time we use that. So the square root of 0 is 0. Square root of 1 is 1. Square root of 2 is messy, so what would be the next number I square root? 4, which would be 2. And then square root of 9 is 3, very similar to what I did on the other side. And you basically get, well, whatever. You get kind of like half of a sideways parabola, of a horizontal parabola. Your domain here is not all real numbers. What number do we start with? 0. And it looks like I can put a bracket there because there's an actual point there as opposed to an asymptote. And then I go on to infinity. Okay, range, same exact thing. Okay, so again, what is it that creates this domain and range? The better you can answer this next question, the more likely you are to remember this stuff from year to year, make the connections. It's not about memorizing separate facts. It's about a system that kind of works together. So can you square root anything you want? What happens when you square root negative numbers? We have a little word, starts with an I. Imaginary. You want to know the best part about calculus? Calculus, at least the earliest calculuses, you don't deal with imaginary numbers at all. Now, if any of you become like engineering majors or math majors, you're gonna get to take a lot more calculus than the rest of everybody. But especially if you're taking calculus here next year, you don't deal with imaginary numbers. So that's kind of nice. So as far as our input is 0 and positive. That's it. And if you think about square rooting 0, we get 0, and if I square root positive, I get positive. So output is the exact same. So again, it's not about memorizing. If you're great at memorizing, maybe it is for you. Maybe that's easier. But I don't think for most people it is. Okay, so how do we, if we saw a little picture, how would we know it was a square root function? What did I say this looks like? It's like half of a horizontal parabola. It's only half because of the whole restriction on square rooting negatives. Okay, also the square root starts at the origin. Now, x squared and square root of x actually have a relationship. I'm going to write it down here. Anybody know what the relationship is between these two? They are inverses. So there's two ways to think about inverses. There's ways to think about it graphically and more algebraically. Okay, so graphically, there's a reflection. Now, it's kind of hard to tell here, but again, if I kind of did something like this, which would make this not a function, so we're just pretending it's there for a minute. It's a reflection. Okay, it's a reflection across, anybody remember what line?
X-axis.
So this is a reflection across itself on the x-axis, but how do I get from this parabola up here to this square root?
Rotation or something?
It is a rotation. It's a 90-degree rotation, or we could think about it like it's a reflect across the line. This is what I'm going to write here. Always works. There's a lot of symmetry with parabolas and all that stuff. So it reflects across the line y equals x. Algebraically, it's just switching the x and the y. So next year, whatever math class you find yourself in, you need to know these things about inverses. That's what we're doing right here in chapter 13. We're reviewing all the stuff that you use a lot in calculus. Okay, so next up we have natural log of x and e to the x. Okay, notice we're not doing every single parent function. We're doing these main ones. And so we would call this natural log. Notice that it's just ln. In calculus, you're not going to deal with log log very much at all. You're going to deal with ln, which is natural log, which is log base e. So some of you had a hard time in this unit. You didn't quite learn it all. So this is good. We're kind of recapping some of this. Okay, natural log has an asymptote on the y-axis. It goes through the point 1, 0. Remember how I made a big deal about that whole natural log of 1 equals 0? You needed to know that, but not put it on the quiz and the test. And then the graph looks like this. So based off of that graph, what is the domain? What number do you start having points at? Or what's a boundary? Like, we're not going to include any of the negatives. So we have a point at 1, but we have all the numbers in between 0 and 1 as well. So 0 is still our starting place, but I'm going to put a parenthesis because there's not an actual point at x equals 0. And then we go on forever. We call that infinity. Okay, range, remember, is bottom to top. It's the y-axis. So looking at this graph, it looks like it goes down forever and goes up forever. So we call this all real numbers. And in interval notation, that would be negative infinity to infinity. So here's a way you can really remember this whole domain if you're not sitting there looking at the graph. Okay? Your input for log is only positive. You cannot take log or natural log of negatives or 0. You can only take natural log of positives. Okay, but there are no restrictions on the output. The output can be anything. One thing about the mini picture here that you've got to remember is that you have a vertical asymptote at x equals 0. If you remember that, that'll also help you with the whole domain. Okay, before we get into this, well, let's just go ahead and write exponential. We've already kind of said that. How are logs and exponentials related? We learned them in the same unit. So how are these two things related to each other? We've already said this word. It starts with an I. They're inverses. Oops. I don't know why I did that. They're inverses. Okay, so that should help us here. So if I reflect this graph, I'm now going to have a horizontal asymptote at y equals 0. And instead of having a point at 1, 0, I'm going to have a point at 0, 1. And the whole graph is going to flip. It's going to reflect across the line y equals x. And this is just a sketch. So natural log was something you just learned about last year. Logs at all. That was brand new last year. Exponential, you started learning about this in Algebra 1. However, this whole e, instead of using another number here, that was new last year. And so this year we learned it a little bit better, and now we're learning it for the second time this year. It should be getting a little bit easier. If it's not, then we need to just go over it a different way. So what do you guys think about the domain? If you look at that x-axis, this goes forever left and forever right. So what's the domain? All real numbers. And then now the range is the one that's going to have the restriction. It's going to start at y equals 0, but not actually touching y equals 0, and then go up. So if you notice, see how they flip-flopped, domain and range? That happens a lot with inverses. Sometimes there's little weird things that happen, but not with here. It was exact switch. Okay, so here for domain, the input can be anything. Think about it this way. Just like how we can square any number, you can take e to the power of any number that you want. But your output is only going to be positive. And this is actually an important thing in calculus. It comes up a few different times, and I remind my students, e to anything, always positive. Not even 0. E to anything is positive. So then what mini picture? Well, it's kind of just that picture, except you got to remember that the horizontal asymptote is y equals 0. The whole point of these notes is for you to remember this stuff. So you write down whatever you need to write down. And then the last parent function we're going to talk about is this 1 over x, which is a fraction. Do y'all remember the other word we use for fraction? Starts with an R. Ratio. So this is a rational graph. And there are actually another one. There's one like this, 1 over x, and sometimes you learned another one that's 1 over x squared that looks like a little volcano. That one's not, we don't use that one as much. But here, think about what's 1 divided by what? If you got to pick what number you had to do 1 divided by, what number would you pick? What's the easiest thing to do 1 divided by? 1. And so 1 divided by 1 is 1. And if you plugged in other numbers, you would get fractions. And so what ends up happening is this looks like this. And then same thing with -1, -1. And what's happening along the x and the y axis? Like, can we plug in 0 here? No. So there is a vertical asymptote here and a horizontal. 0 is off limits here, both as an input and an output. So the way we would write that for our domain is -∞, and we'd skip over 0, and this is where we do the union, and we'd pick back up at 0. And the range would be the exact same thing. You'd skip over 0. So domain and range are both numbers less than 0, numbers greater than 0, but not 0. Absolute value is the v, which we're not really going over today because it's kind of in its own category. I'm going to go over some of these that I've skipped. I'm going to go over on the next page just briefly, but the ones that you're going to deal with the most, these are the ones that next year, these are the ones we're doing. Okay, so I kind of already said this, but what number is off limits for both domain and range? 0. So your input cannot equal 0. It can be positive, it can be negative, it cannot be 0. Same thing with the output. You're not going to get 0. If you do 1 divided by something, it's never going to equal 0. So your output also cannot equal 0. So some things you got to remember here is that you have both a vertical and a horizontal asymptote. At x equals 0, y equals 0. And then anything else. Again, these notes are not to impress me. They're to help you work the problems. Okay, so if you look on the next page, there's some repetition. Okay, and so you need to be able to kind of draw like a little mini picture. Looks like my pen is going haywire. Oh, there we go. Okay. So what I would like for you to do is to kind of, as many of these as you can do, I want you to draw a little picture. You should be able to at least do a few of these because we've already done them today. So I want you to try to do as many as you can. Okay, so these are the ones that we kind of already had on the front. Do y'all remember what cubic looks like? Like if you had to describe it in words, you may say it kind of looks like an S. It looks something like this. And cubed root is very similar. It's just flatter. It's more like this. Very similar. Okay, here's what you need to remember about sine and cosine. They both do the wave. Which one starts at a peak? And which one starts at the origin?
Sine's at a peak.
So sine of 0 is...
I don't know.
That's okay. I'm just going to answer your question with another question. What, or anybody, what's sine of 0? 0. And this is where knowing your exact values is going to even help you with this. So sine of 0 is 0. So sine is actually the one that starts at the origin. Cosine of 0 is 1. So cosine starts at a peak. And then they both do the wave. The only difference, and those are kind of messy, but the only difference is where do they start. And this was all chapter 2 stuff. If any of you wanted to, you're like, I want to learn more about this or review this more. This is chapter 2. Okay. So if you know your parent functions and you know the basics of transformations, you can really graph almost anything, at least a sketch. So up, down, left, right transformations, we've covered that several times over this semester. Okay, we also got reflections, stretches, shrinks, all that kind of stuff. So with y equals e to the x, here's the parent function again. This is a very important one, so that's why we're kind of getting it in a whole lot on this worksheet. Do you remember what this arrow means right here? Approaches. Because you don't ever get to infinity. You don't go, hey, I reached infinity. You just approach infinity. So as x approaches infinity, which would mean as the graph moves to the right, what is y approaching? It could be a number, and it could also be infinity. In this case, positive infinity, because going up. All right, but if we reflect this thing over the x-axis, which, by the way, that graph would look like negative e to the x. As x approaches infinity, as x gets bigger and bigger and bigger, y is getting bigger, but in the negative direction. So we'd have negative infinity there. This is not how it's going to happen for every parent function. You kind of have to just think through it for each one. Okay, if we reflect over the y-axis, remember here's the y-axis, here's the x-axis. So instead of starting out flat and going steep, we start steep and then go flat. Where do you think the negative would be for this one? Any ideas? Up by the x. So instead of trying to remember, just look at this graph. As x gets bigger and bigger and bigger, what is y getting closer and closer to? 0. It's not about, you can't memorize all this information. It's a system, and you got to have a toolbox and be able to pick out the right tool. And knowing your parent function and your transformations helps that. Okay, we're actually just not going to do this. I'm sure y'all are upset about not writing complete sentences. Okay, if you look at the next part, it's multiple choice. And if you skip to the very end, I'm just going to kind of let you in on a secret. There's a little blank here. So once you get some of these, if you can figure out the saying, that could help you with some that you're stuck on. Okay?